Okay, so now for the new parts in chapter 1. Okay, so we have previously learned on domain and range, right? So I have introduced the function of 2 or 3 independent variables. Okay, so the next part is on how can we get the graph for the given function. Okay, for this part, specifically for a function of 2 independent variables. Okay, so previously when we are talking about with for a function with single independent variable, okay, it's gonna be in 2D graph. For example, if we have y equal to x, for example. Okay, so if we sketch in 2D, okay, so we have x-axis and y-axis, right? So whenever we have y equal to x, okay, it's gonna be a straight line like this. Okay, it's gonna be a 2D graph. Okay, so I would say that a function with a single or one independent variable will be easy because that is the thing that you have learned previously. Okay, but then okay, when we talk about a function of two independent variables, okay, so you're gonna have a surface or the graph will be in 3D, okay, instead of 2D, but you still need the prior knowledge on the 2D graph that you have learned previously in order for you to get a 3D graph. Okay, because as much as you can see, okay, to get a 3D graph is not easy. Okay, so the graph will be like this. Okay, it's gonna be a surface. Okay, the graph that you're gonna sketch for a function with 2 independent variable is called as a surface in 3D surface. Okay, so it's important for you to be able to get the correct surface. Okay, in order for you to understand and to learn for the following chapters later. Okay, so yeah, in this particular part we're gonna focusing on the graph sketching, but in the following chapters later on, okay, you're gonna use, okay, the knowledge that you have learned, okay, in this part for you to be able to go through another chapters. Okay, so when we talk about a 3D graph, okay, so instead of we have 2 axes like this, so now we have 3 axes. Okay, so we have x, y, and z. Okay, so if in 3D graph, okay, so we're gonna have a coordinate planes, right? Okay, so we have this side. Okay, so this side, yz plane. Okay, whenever x equal to 0. Okay, so in this side, okay, if you take a look on this one, so this part is gonna be xz, since I put x over here. Okay, so how can I say for this part, the position of the axis, okay, because like I said, to sketch a 3D graph is not easy. Okay, so my suggestion, okay, you can just change the position of the axis. Means that if you think that you are more comfortable to draw in this position of the axis, you can use this position, but you can just instantly change, for example, y, x over here, and z in this position, because we can just flip easily the coordinate, or it's not the coordinate, the surface. Okay, how you see or how you view those surface that you're gonna sketch. Okay, so in this case, okay, it's gonna be a z plane over here, but if you take a look on this part, you're gonna have yz plane in this part, and on the bottom over here you're gonna have xy plane. Okay, so it can be in any position for the axis as long as you label it correctly. Okay, I will not ask you to fix in certain position, okay, because I know it's very hard to sketch, okay, to sketch correctly. Okay, but you will get an idea later on. Okay, so when we talk about 3-dimensional coordinate system, Okay, so it can be divided into 8 octants, okay, as shown over here. Okay, so the easiest way to detect is when you have a normal a positive values of x, y, and z. It's gonna be in the first octant. Okay, so it means that in the first part of here. Okay, so as you can see over here, it's gonna be a positive values of x, positive y, and positive z. Okay, so you can see on the other octant as well. Okay, so for the octant, okay, normally when we ask you to sketch, for example, if we give you a specific direction that's saying in the first octant or second octant, okay, it's very rare cases, okay, but we will only what should I say, you should know, okay, in which octant the point is, okay, but sometimes, okay, we also ask you to draw the surface, okay, by giving a hint for you guys, okay, that surface will be in which octant, okay, and the popular octant that we always use normally is first octant only, because it's quite straightforward. Okay, so okay, so like I said, okay, you have learned previously on how can you sketch in 2D. Okay, so let's talk about on how can we sketch the graph in 3D. Okay, so we have two options over here. Okay, if one variable missing, okay, whether x, y, or z over here. Okay, so first thing first is for you to determine the variable. Okay, and then sketch the trace in coordinate plane. Okay, and then make the projection which is parallel to the variable which is not exist in the axis. Okay, so the idea is we use trace, okay, or we call it also trace means that you're gonna sketch in 2D, okay, for the existing variable, okay, if let's say you miss one variable, okay, and then you're gonna combine it. Okay, okay, so let's go through over here first. Okay, so sketch the trace and then make the projection. Okay, so this is the first idea on how can you sketch the graph. Okay, so the second part is if no variable missing. Okay, so you're gonna sketch, okay, you're gonna sketch the trace, okay, for each, okay, for each plane, coordinate plane, okay, xz plane, yz plane, and xy plane. Okay, so please remember that the level curve or contour map is actually on xy plane. Okay, so in order for you to know whether your sketching is correct or not is normally for you to check the domain and range. From there, you will actually get an idea whether your surface that you sketch is correct or not. Okay, so that's the manual procedure on how can you get the graph. Okay, so let's take a look on the second example over here. Okay, so the question asks you to sketch the graph of each of the following surface in 3 dimensions. Okay, so now we talk about 3 dimensions. Okay, so let's take a look on the first one. Okay, so we have z equal to 5. Okay, so if we imagine, okay, whenever we have a constant equation with one variable only, mean that we are missing for in this case for x and y. So x and y is not available. If it's not available, we can assume that it can be any values of x and y over here. Okay, so if we sketch in 3D, you have x, you have y, and then we have z. Okay, so we knows that z equal to 5 is somewhere here. Okay, but whether it will be a straight line, okay, or not. Okay, but since it's 3D, like I said, okay, whenever we would like to sketch a 3D graph, okay, instead of a straight line, you should have a surface. Okay, so in this case, you're gonna have a plane like this. Okay, I'm sorry for my bad sketching. Okay, but you're gonna have a plane. Okay, a plane at the level of z equal to 5 for any values of x and y. Okay, so if I give you another example, if I give you x equal to 4 into the graph, okay, for example, x and y over here, x equal to 4 should be a straight line like this, at x equal to 4 over here, x equal to 4. But if we would like to get in 3D, okay, for example, if I put y over here, z over here, and then x over here, so that will be easy for you to sketch. Okay, the struggle to sketch a 3D graph is not it's not only apply for the student. Okay, it's struggling for me as well. Okay, so it's gonna be somewhere here, so you're gonna have a plane like this. I do hope that you can actually, be able to imagine what I'm trying to say right now. Okay, but the idea is you will not get a straight line, you will get a plane. Okay, plane or surface. Okay, so that's how you solve for the first one. Okay, what about the second one? Okay, so for the second one, we have y equal to negative x plus 6 over here. Okay, so if we sketch in 2D graph, okay, so you're gonna have x, y over here. So it's gonna be like this, 6 and 6, right? Okay, so if in the first part, okay, means that if we only have one variable, okay, means that y and x is gonna be any values. In the second cases now, okay, we do not have the values of z. Okay, if we take a look on the manual procedure in getting 3D graph, okay, so you're gonna make the projection which is parallel to the missing variable. Okay, so now if we sketch it in 3D graph, x and y over here, okay, so we have x and y over here, right? So you're gonna have a rectangle like this. So means that you're gonna make a projection, I would say, okay, parallel to z axis. Okay, so you're gonna have a plane like this. Okay, a plane like this. So means that it can be any values of z. So you're gonna have a plane in this way. Okay, because you do not have the values of z over here. Okay, and then the third one. Okay, so the third one, okay, you do not have any missing variables. Okay, so this is where, okay, this is where we applying the trace. Okay, oh yeah, before I forgot, okay, in these cases as well, okay, so this is what we call trace as well. Means that trace means that you sketch in 2D first, okay, and then from there you will project, okay, what kind of surface that you should get. Okay, so in this case, okay, so in this case we do not have any missing variables. Okay, so we're gonna start with the first trace, okay, which is on xy plane. Okay, so the easiest way to get on xy plane, we set z equal to 0. So we're gonna have x plus y equal to 1. Okay, so if you sketch in 2D, so it's gonna be like this, x plus y, so it's gonna be like this, right? 1 and 1. Okay, so the next one is for you to get the second traces at z plane. Okay, in order for you to get on z plane, okay, so the easiest way is for you to set y equal to 0. Okay, when we have a complete variables in one equation, okay, to get the traces means that we're gonna set the other variables that is not involved in that traces as a 0, or we make it that equation become an equation with two independent variables only. Okay, so that's why the easiest way is to set z equal to 0. So you're gonna have like this. Same goes to this one to get a z plane. Okay, so you're gonna have at plus z equal to 1. Okay, so if you sketch, you're gonna get the same graph. It's just that the axis is different. And the last one is yz plane. So in this case, you set x equal to 0. Y, z over here. Okay, so now we have all the traces over here. So now we'll combine it. Okay, if you combine it, okay, if you sketch it in 3D like this, x, z, and y over here. Okay, so if you sketch it, you have 1, 1, 1 over here, because you got it from this part, right? This part. So if you combine it, you're gonna have like this, a surface like this, or we also call it as tetrahedron. Okay, so that's how we sketch it. Okay, whenever we have an equation with a complete variable, mean that with all variables x, y, and z. Okay, so it's depend on the question as well. Okay, on what you should set, okay, in order for you to get the correct traces. Okay, so the idea is, okay, to sketch the correct traces first. Okay, in order for you to get the correct traces is to use the prior knowledge. Okay, so I would like you to go through example 3 over here. Okay, will you get, okay, this have a bracket over here. Okay, will you get this kind of surface, okay, if you sketch it? Okay, so in this case, okay, you have one variable missing. Okay, so you're gonna get the graph based on B, like what I explained just now. Okay, so you can refer to this kind of shape, okay, at the back of this note. Okay, thank you.